So in this video, I will be going over limit laws, and what limit laws basically are the rules that you have to follow when evaluating limits. So here on the screen, you can see a whole bunch of limit laws, and in this video, I'll try to explain when to use them and how to use them and why. So here we can take a look at the graphs of two functions, f of x in red and g of x in blue, and we can try to find the limit as x goes to 0 of f of x plus g of x. So according to limit laws, what we can actually do is take the limit of the two individual functions inside. So what happens is we can split up the f of x and the g of x. So the end result would look like this. So at this point in time, we can evaluate the limits of both parts. So the limit of f of x as x goes to 0 is 1, plus the limit of g of x as x goes to 0, which is 3. And the answer would be 4. So this idea that we can evaluate separate parts of the function works not only for addition, but also for subtraction, multiplication, and division. So let's look at another example with division. So like last time, we're taking the limit of both parts of the function, and this time we're dividing them. And now we can also evaluate the limits by themselves. So the top part would be 2. But if you look at the g of x function, it does not exist. So what we're going to put is does not exist. And so looking at this, even though the limit of f of x exists, g of x does not exist. So overall, the limit as x goes to 3 does not exist. So let's look at one last example, and looking at this function like last time, we should break it up into its parts. So that would be the limit as x goes to 0 of 2 f of x plus the limit as x goes to 0 of g of x all over the limit as x goes to 0 of g of x. So as we continue to simplify, we can see that there's a coefficient of 2 in front of the f of x. So what we can actually do with the 2 is bring it out in front and multiply the entire limit by 2. And that would look like 2 times the limit of f of x as x goes to 0 plus, and now we've gotten to a point where we can just solve the g of x terms. So that would be equal to 3, and the same thing on the bottom, 3. And this simplifies to 2 plus 3 over 3, which is 5 over 3. So this whole process of splitting the function into separate parts may seem kind of unnecessary, as we could have gotten the same answer of 5/3 just by plugging in the 0 in the beginning. But this is more to show why we can do that and why we can direct substitute. So from now on, we no longer have to write out the limit notation, and all we have to do is direct substitute the value that we're trying to get to. So let's just go over direct substitution really quick. So we have the limit as x goes to 2 of square root of x cubed plus 1 all over x plus 2. So we can just plug in 2 and get 8 plus 1 all over 2 plus 2. And that's equal to root 9 over 4, which is equal to 3/4. So direct substitution can also be helpful when trying to solve piecewise functions. So let's look at this function f of x, where it is equal to x squared when x is greater than 0, and x minus 1 when x is less than or equal to 0. So notice here that we're trying to find the limit as x goes to 0, and 0 falls in between the two functions. So we'd have to test the values of both the left and right hand side. So let's go ahead and do that. So 0 squared would be this side, which is equal to 0, and 0 minus 1, which would be negative 1. And 0 is not equal to negative 1, so therefore the limit does not exist. So we can go ahead and confirm that with the graph of the function. So you would have x squared and then x minus 1, and you can see that the functions don't meet up at the same point, so the limit does not exist. So direct substitution is usually the easiest way of finding limits, but that doesn't always work because sometimes it makes the denominator equal to 0. So let's take a look at this function, and immediately you notice that if you plug in 2, you would get an answer of 0 over 0. So we have to find another way to get the x minus 2 on the bottom to cancel. So let's just go ahead and try to factor the top, and that would be equal to x plus 3 times x minus 2 all over x minus 2. And you notice that there's an x minus 2 on both the top and the bottom, so we can just cancel that. And from here, we can just plug in 2 into the x plus 3 and get 5. So we can do this because we're not actually trying to find the value at x is equal to 2, rather we're trying to find what it approaches as x goes to 2, and it ends up being that there's a hole at 2, 5, and the function does not exist there, which is why we can't direct substitute. So now that we know that when direct substitution doesn't work, you have to try to factor and cancel, but even sometimes that doesn't work, and what we have to do then is resort to left-hand side and right-hand side limits. So let's look at a really simple example, the limit as x goes to 0 of 1 over x. So obviously when you look at this, there's no way to direct substitute, and there's no factoring or canceling going on here. So all we have to do is look at the left-hand side and the right-hand side, so let's go ahead and do that now. And what we're going to do is we're going to take the limit as x goes to 0 from the left side, and the limit as x goes to 0 from the positive side. So now we can just plug it in, and we get 1 over a really small negative number, so that would be equal to negative infinity. And on this side, we got 1 over a really small positive number, so we get positive infinity. And because these are not equal to each other, you can go ahead and say that the limit as x goes to 0 of 1 over x does not exist. So now we can try to put everything together and try to find the limit of this function. So first, we try to direct substitute the 2 in, but when we do that, we realize we get 0 over 0, so you have to move on to the next step. So next step, we can try to factor the top, and what we end up with is x plus 5 times x minus 2, all over x minus 2. And right away, we can see there's a possible cancellation of the x minus 2's, but we can't do that just yet because of the absolute value sign on the top. So that means we have to resort to left-hand side and right-hand side limits. So from the left-hand side, we get the limit as x goes to 2 from the negative side of the absolute value of x plus 5 times x minus 2 all over x minus 2. And when you plug that in, you get x plus 5 times 0 from the left side all over 0 from the left side. And now, because this whole top part becomes negative, we take the negative of the whole thing and drop the absolute value signs. And now we can see the zeros cancel, and we get negative x plus 5. And then you can go ahead and substitute 2 in, and you get negative 7. So now that we know that the left side limit is negative 7, we can go ahead and solve for the right side limit. So we take the limit as x goes to 2 on the positive side of the absolute value of x plus 5 with x minus 2 all over x minus 2. And when we do that, we get x plus 5 times 0 from the positive side all over 0 from the positive side. And because the top remains positive, you can just drop the absolute value signs, and you're left with x plus 5 times 0 from the positive side all over 0 from the positive side, which cancels. And now you can plug in 2 and get that the answer is 7. And then we can compare the right-hand side and the left-hand side limits. So the left-hand side would be negative 7 and 7, and they're not equal to each other, so we can say the overall limit does not exist. So let's just try to recap everything that we've learned today. So when trying to evaluate limits, the first thing is to try to substitute in the value. But when that doesn't work, we have to try to factor and cancel. And when that doesn't work, we have to try to do left side and right side limits. So overall, some things to note are when adding, subtracting, multiplying, or dividing limits, all parts of the limits must exist. So if it's a real number times a does not exist, the overall limit ends up being does not exist. And one more thing to note is when doing left side and right side limits, you have to keep track of the negative signs and positive signs because they're really important in finding the end result of the limit. So overall, I hope this video helped in explaining how to find limits, and thanks for watching.